Hey guys, welcome to this video, which will begin with new content, starting with Unit 6, Part 1, Inference Procedures. And we'll begin with this new point, confidence interval. And our main goal for this whole chapter, or at least at this point, is that we want to estimate a population mean, or mu, from a sample mean x bar. So we're given an example in here, which is we want to estimate the mean IQ mu for all students. We take an SRS of n is equal to 40 students and administer an IQ test known to have a population standard deviation equal to 10. And our sample mean x bar is equal to 107.2. So we're beginning with our procedures right now. If you take a first glance at this question at the beginning, you might be wondering, what should I do with all of this information? It seems like overwhelm. It gives us a lot of numbers, and it's kind of confusing. I mean, it's pretty common, and I will show you 4 steps right now, which will help you to deal all of those questions later in the future. And it's called a 4-step procedure rule. So we'll begin with our first step, which is state. And it basically asking us to state the population parameter. And remember, always put your variable into context to explain based on your background that's given to you. So in this case, the mu is going to be the average IQ score for all CCHS students. The second step is plan, and it's plan name of procedure and conditions needed for its use. So what's the name of our procedure? Well, it's 95% z interval for one mean. You might be wondering, where did you get the 95% from? Well, I got it from nowhere. I actually made up for that. And the reason for it is that the original question didn't give us any confidence interval at the beginning or alpha values. So I just make up one, which is a kind of common one. You will see more of those similar numbers later as you do more and more of those questions. But normally, in most of the cases, the question will give you a percentage, but it didn't in this case, so I just make up for it. And the conditions needed for its use, well, there's 3 conditions we have to meet. The first condition is going to be SRS, which is simple random sample. And is it met? Well, it is, because it's given us from the original question. The second condition is going to be more than 400 CCHS students. Where does the 400 come from? Well, it's 40 times 10, because this rule is simply asking us, is the sample size less than 10% of the population? And it is, because we have more than 400 students in this high school. So because this condition is met, we can draw the conclusion, which is the standard deviation of the sample is going to be equal to the standard deviation of the population divided by the square root of the sample size. And we get this number right here, 10 divided, 10 over square root of 40. And we're moving on to condition 3, which is the sample size. Is it greater than 25? Some textbook will say it's greater than 30 or not. I mean, I normally use 25 as a cutoff point, but you can use 30 as well, especially if your professor or teacher is asking you to do that. But in this case, because 40 is greater than 25, then the sampling distribution is normal, because we have enough sample size. Okay, so the third step is going to be do. Pretty easy, right? At least from the meaning. We're going to do the mechanics and calculate the interval. And this is the formula that I think simply just you have to memorize it. It's going to be x bar plus or minus z star times the standard deviation. Basically, this is the standard deviation of the sample we just calculated from here. And what does this part represent is that this is the margin of error. And if we plug all of the values in this question into this formula, we will get 107.2 plus or minus 1.96. Well, where does the 1.96 come from? Well, 1.96 is the z star, and what you can do is that on your calculator, okay, let me grab my calculator really quick for now. So on your calculator, go to normal, inverse normal. And because we want to use the 95% confidence interval, so you can, on the area part, you can just type 0.95, and don't change the mu and the standard deviation. Leave them as 0 and 1, and then go into tail, hit center, and then paste. You will get 2 equal amount of number, but opposite signs. So for simplicity, we can just use positive numbers, which will be 1.96. There's also a negative 1.96, but you can just use this. It does not make a difference. So use this and times the standard deviation we just got from here, and you will get a range of data, which is from 104.1 to 110.3. So this is where we at the point that we can conclude in context for this problem. So what should we do? What does this interval of number really means? Well, it means we are 95% confident that the true average IQ of CCHS students is between 104.1 and 110.3. So that's it. That's for our first like 4-step procedure problem, and we did it together. We successfully did it. And just don't forget like to put everything that you get, either it's a variable or it's a number or something, put it into the context and explain in your own words. That's the main goal of those type of questions. And in here I just want to jot down a few notes right here, which is the z star, or like the critical values in here. Because we use the 95% as our z interval for this question, which is 1.96. We did it on our calculator. But there's some very common z intervals, such as 90% or 99%. And those are the numbers that's like, I mean, you can also use your calculator on the test to quickly find those. But if you can just memorize those, it will be much easier. So like z star for 90% will be 1.645, and z star for 95% will be 1.96. Z star for 99% is going to be 2.58. So z star in here just means the critical values that we're using to find our intervals of the question. So